Okay, number 5. So the score when a spinner is spun is given by the discrete random variable x with the following probabilities. Alright, so it looks like we've got 5 points here, and the probabilities are unknown, where you've got b, 3 a's, and another b. Now the first thing you should always do with these kind of questions is always form an equation, yeah? So I said that the sum of all of these probabilities always adds up to 1, okay? And when you do that, you can do something on the right, like I did here. So if you add them all up, you should get 3a plus 2b equal to 1. So let's look at A and B now, questions. So explain why the expected value of x is 2. So why is the mean 2? Well, one way to explain it is that, without using math formulas by the way guys, is that if you look at these, the way the probability is laid out, it looks like it's a pattern. You got b's on the endpoints and you got 3 a's in the middle. This is actually symmetrical. If you think of this as a symmetry, bang in the middle is symmetrical on the left and the right. So that's one way to look at it. If the mean is symmetrical, then the mean is definitely the middle. So the mean will be 2 due to symmetry. Now, if you do it mathematically, firstly, let's go ahead and find what EX actually is. So first thing, so expected value literally means X times the probability. So it's going to be, in this case, minus 1 times B, which is minus B. 0 times A is nothing. 2 times A is 2A, and so on. And then you get something like this. So when you collect like terms here, you should get 6A plus 4B. Factorize the 2 out and you get 3A plus 2B inside. Now this is quite important because if you think about it, when we collected probabilities, and if you did this already, you'll see that 3A plus 2B is equal to 1. So that means you got 2 times 1, which is 2. So that's 2 ways. Now let's go to the next bit. So B is actually done already. So next one, C and D. So given that the variance of x is 7.1, so straight off the bat, write a variance equation like I did here, which is equal to expected value of x squared minus the mean squared. And x squared literally means that you write an x squared here and make a new table. Okay, so here, so find the second equation in A and B to simplify your answer, and then solve both equations from part B and C. Okay, so let's do this. So let's find out what EX squared is first, so that way we can go ahead and solve this. So EX squared literally means square each of these variables and then times against the probability. So let's have a look. So minus 1 squared is plus 1. So 1 times B is B. 0 squared is 0, so that's nothing. 2 squared is 4, so 4A. 4 squared is 16, 16A, and so on, 25B. And then collect like terms here, and you should get 20A plus 26B. So that's the value of EX squared. Now, if we look at this formula again, we have the value of variance of x, which is 7.1. So I'll put it over here. So variance x 7.1, EX squared, we just got it. Oops, and this is meant to be the mean squared, by the way. Little typo there. So the square should be outside. And this value here should be 4 because we know the mean is 2, so it'll be 2 squared, which is 4. And then they want you to simplify. So what I do is just plus 4 across, so you get 11.1 and make it equal to the equation. Now, to solve this, you notice that you have two equations. You got this one here, and you got the probability equation we did earlier on, which is equal to 1. So I just line them up like you do in a linear way, and then choose your method, substitution or elimination. For me, because it's linear equations, it's just easier to eliminate. So I literally just multiplied the probability equation by 13. So then the b's match up, so you get 26b. That means if you multiply the rest by 13, you get 39a from 3 and 13 from 1. And then you can just subtract the first and last equation to get 19a equals 1.1. Divide by 19 to get 0.1, and then plug in 0.1 to any of these equations for a to solve for b, which will give you 0.35. And that's it. So let's move on to the next set, guys. Okay, here we go. So yeah, just quick tip. So I've copied out the previous table and you'll see that I've added a few more things, but we're going to go through it. So let's have a look. So the discrete random variable y equals 10 minus 3x. So what this means is that you use the x values from your table, plug into the y equation here, plug into this formula here to get an expression for y. For example, if you plug in x equals minus 1, you got 10 minus 3 times minus 1, which will give us 13. And I just did the rest for the same. This is gonna be helpful for part F in particular, and maybe E, but not really. So E, find the expected value of y and the variance of y. So EY literally means that you just take expected value on the whole equation, so 10 minus 3x, and using the properties, if you take the expected value 10 of constant, it's just the constant is 10, If you take E on 3x, well, you only focus on the x. So everything else goes outside. So you're left with 10 minus 3 times the expected value of x. And EX, we already know, is 2 from part A. So that means it'll be 10 minus 3 times 2, which is 4. So that's done. Now the variance is similar, but things disappear. So you take the variance on y, so wrap it around the whole 10 minus 3x. The variance of a constant is 0, by the way. So because variance means the spread, and there's no spread around a fixed number. So that's 0. And then the variance of minus 3x, well, you always square the constant. So you got square minus 3 to get 9. And then the variance x, we already know. It was given in over here at 7.1. So you're left with 9 times 7.1, which is here, 63.9. You guys can double check my answers, by the way. I haven't really verified them. And now finally for F, which is here, and it says the spin is spun once. So this means we're looking for a single probability option, yeah? Find the probability when y is greater than x. Now this is related to what we did here. So you see this table here, we literally just see when y is bigger than x. Well, we can see it's bigger on when we can see that 13 is bigger than minus 1, 10 is bigger than 0, and 4 is bigger than 2. So it occurs 3 times, and these probabilities are equal to these 3 here. So 35, 0.1, and 0.1. And that's it. You just add them up and you get 0.55. Yeah, and that's it, guys. That's literally number 5 done.